Alright, y'all, we're going to do some more stuff with arithmetic sequences today. The goal for this first example is we're going to find D, and we're going to use that value of D to figure out some terms that are in between two other terms that we give you. So, there are two ways to do this. The first way is using our rule for arithmetic sequences, using this formula, we're going to plug in things that we know, and then we're going to solve for D. So let's see what that looks like. Here we've got a term, 3 blanks, and another term. So that means we've got 5 total terms. So I'm going to call this a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Those are each of my terms, and we have 5 terms. So when we're solving for D, in our formula, the things that we know are a sub 1, which we have, and then this a sub n. Well, the only other term in our sequence that we know is a sub 5. So we're going to have to use a sub 5 in this situation, and we're going to solve for D with the a sub 1, and in this case the a sub 5. A sub 5 we know is negative 17 equals, we're just substituting things into our formula, a sub 1 we know is 11, plus, now we used a sub 5 here. So that means our n is 5. So in the parentheses, we've got 5 minus 1 times d. D is the thing that we don't know yet. We don't know how much we're adding or subtracting to get from one term to the next. So we're going to have to solve for d. Now on this right side, I'm going to simplify it first. So we have negative 17 equals 11 plus, and 5 minus 1 is 4. So we have plus 4d. Subtract the 11, negative 28 equals 4d, and then divide by 4. So here D is negative 7. That means we're subtracting 7 from each term to get to the next one. So we have minus 7, minus 7, minus 7, and minus 7. So let's figure out what those terms are. 11 minus 7 is 4. 4 minus 7 is negative 3. Negative 3 minus 7 is negative 10. And negative 10 minus 7 is in fact negative 17. Which means that we got the correct value. Now, the other way to figure out D is to first, from the rule for arithmetic sequences, first solve for D before you plug anything in. So here's what that looks like. So here's our original rule for arithmetic sequences. If we were going to solve for D, the first thing we would have to do is move that a sub 1 over. So we have subtracted a sub 1 from both sides, and then we're going to divide by n minus 1. So here we could also use this formula to find D, and then plug in our numbers. So what that would look like here is D equals, we're still using the same numbers, so we're still using negative 17 minus 11 over 5 minus 1, which is negative 28 over 4, which is still negative 7. So notice we got the exact same number for both. So you could use either one of these versions. They are technically the same thing. It's just the only difference is when you are plugging in your numbers. In this first way that we did it, we plugged in the numbers at the very beginning and then solved for D. In the second way that we did it, we solved for D first and then plugged in our numbers. But we get the exact same answer, so you can do either one. You can start by subtracting your last term and your first term, and then dividing by n minus 1. Now, if you want to see more examples of these types of problems, you can watch the next video. I'm going to put them in the next one. If not, I have another type of problem that we need to look at. In this example, we need to find the 6th term of the arithmetic sequence, but we are given a sub 9 and a sub 14. We don't know a sub 1. But we're still going to use the same idea that we just learned to figure out what our value of D is, and then we're just going to work backwards from a sub 9 to get to a sub 6. So first, I'm just going to draw a whole bunch of blanks and fill in the blanks that I know. So I get up to a sub 14, so let's draw 14 blanks. I know a sub 14 is 195, and I know a sub 9 is 120, and I'm looking for a sub 6. I'm looking for that 6th term. 1, 2, 3, 4, 5, 6. Here's a sub 6. So in this situation, with our two values, we're going to use that second method that we learned where we solve for D first and then plug stuff in. So what that looks like here, our last term is 195, minus the first term that we know, and we're dividing by, in this case, to get from 120 to 195, we were going to treat this 120 as our a sub 1. So this is a sub 1, 2, 3, 4, 5, 6. So we're going to do dividing by 6, that's our in, minus 1. It took 6 terms to get from 120 to 195, and remember it's supposed to be minus 1. So then when we do that, 195 minus 120 is 75 over 6 minus 1 is 5, and 75 over 5 is 15. So that means between each term, we are adding 15 from one term to the other, to the other, to the other. Now, if we're going backwards, we want this term that's in front of 120 plus 15 to get me to 120. So to go backwards, we're actually going to have to subtract. So something plus 15 is 120. That something is, we've got 105. Something plus 15 is 105. That's 90. Something plus 15 is 90. That is 75. So a sub 6 here, working backwards, is 75. All right, again, if you want to see more examples of solving for D and using that value, watch the next video. If you think you have a good grasp on it, you're good to go and you can go ahead and start the assignment.